All right, we're going to look at 1, 2, and 3 on page 211. And I was just saying that these are not necessarily in the order that they are on your note card. And I like to go through using the same order each time. So the first thing I would figure out is my y-intercept, because that's the step 1 that's on our note card. So when we plug in 0, we get what? 0 in the numerator, and we get 6 in the denominator. So 0 divided by 6 is 0, right? So our y-intercept would be at 0, 0. And then usually our second step on our note card is doing the x-intercepts. And for the x-intercepts, where do we look? Someone from the crowd. What's your note card say? To do the x-intercept, where do you look? The numerator. So what will force my numerator, 5x, to be 0 when x is 0? It should kind of make sense that if the y-intercept is 0, 0, the x-intercept also has to be 0, 0. All right, and then our step 3 on our note card is usually finding our vertical asymptotes. And where do we look to find vertical asymptotes? The denominator. What can I plug in that will make x plus 6 be 0? What would be undefined in this function? 0, -1, 6. What do I have to plug in that I'm going to get 0 here? -6. So I write that as x equals -6, because that's the equation for a vertical line for that asymptote. And then our last step on our note card is to find that horizontal or slant asymptote. So it says indicate the type. That just means, is it horizontal or is it slant? And then write it as an equation. So I compare the power of the numerator with the denominator. I have a linear function over a linear function. So they tie in power. So how do I find the horizontal asymptote? It is going to be horizontal. I take the coefficients of the x's, 5 over 1, 5x over 1x. So 5 over 1 is 5. So I write that as the horizontal asymptote y equals 5. And on this one, I didn't have to graph it. I just had to find those 4 parts of my answer. What? Calculate the second half of it to be able to check some of your answers. All right, so how about this one? Let's go in the same order. So let's find our y-intercept as our step 1. So to find my y-intercept, I plug in 0 for everything that has an x. So I would get 0 divided by 2, which again is 0. So I need to be careful on the second step, the x-intercepts, because this numerator factors. And so I should have probably factored this to look for any holes first. So if I'm going to factor the numerator, what strategy should I use? I always look for this first. GCF, I can factor out an x squared. And what will I have left when I factor out an x squared? X minus 4. And what about the denominator? So this is a trinomial. So I'm going to see if it's factorable. What are the factors of 2 that would add up to 3? So x plus 1, x plus 2. So it looks like I have no factors that are going to cancel, but at least now everything's factored to do these steps. So that's where 0, 0 is coming in, right? This was a y-intercept at 0, 0, so it also has an x-intercept at 0, 0. I mean, remember that thing about multiplicity? Something funky might happen at that 0x intercept, like bouncing off the axis. It could. Yeah, so, but it can't have 2 x-intercepts. It just has an x-intercept at 0, 0. And it may behave interestingly, based on end behavior. All right, and then what about this x minus 4? So I have a second x-intercept at positive 4, because 4 minus 4 will also give me 0. So 0, 0, and 4, 0, I have 2 x-intercepts. So that's why just because there's a y-intercept at 0, 0, it doesn't mean that that's the only x-intercept. So you still want to go through and actually look at the numerator and verify what the x-intercepts are, so you don't miss one. And then our step 3 is always looking for the vertical asymptotes, which would be in the denominator. What would make this denominator undefined? There's 2 vertical asymptotes this time. Yep, when x is -1 and when x is -2. So I have 2 vertical asymptotes. All right, then I look in standard form at the power of the numerator and the power of the denominator, and who wins? The numerator wins. And what happens when the numerator wins? You're doing division to find a slant asymptote. I might need just a little bit more room to do this on. All right, so I'm trying to divide this dividend, which is x cubed minus 4x squared plus 0x plus 0. I'm just writing that as my dividend, so as I go along, I know that I don't have any of these things. Sorry if I didn't give you quite enough room. You might be able to do it up here, like above the question. There's a bunch of space on your paper. So we are going to do this trinomial as our divisor. So our trinomial is x squared plus 3x plus 2. So x squared plus 3x plus 2 is going to go down the side of our box. So I'll give you a second to just get that set up somewhere on your paper or on another piece of paper. This is going to be our dividend that's going to show up inside the box. This is our divisor, and our asymptote is going to be up here at the end. It's going to be whatever our quotient was. So you can expect to have to do division at least once or twice on your test. Probably once in like the multiple choice section, and then once when you have to physically graph it. All right, so I put x cubed here because that's the first term of my dividend. Then I need to figure out what goes in my quotient so that this times x squared gives me x cubed. So this term has to be what? Just x. X times x squared is x cubed, and now I do these 2 boxes underneath by multiplying. So I do x times 3x, and I get 3x squared. Oops, I shouldn't have written that there. And then x times 2 is 2x. All right, so now the only box that you're going to look at next is this box right here, because these 2 boxes are going to have x squareds in them. And how many x squareds are in your dividend? -4x squared. So to add these together, what has to go in this box to get -4x squared? Yeah, -7x squared. So these 2 circles together, adding them, add up to -4x squared. So what's the last term of my quotient? What has to go here so that when I multiply, I get this circle? No, because I'm only multiplying by x squared. So I can multiply by the whole number, -7, right? Yeah. So -7 times x squared is -7x squared. This is your slant asymptote. Y equals x minus 7. If you want to go the whole rest of the way, you're going to be finding your remainder. I'm just going to skip that for now because I know already that nothing canceled. So I know that this is not going to be an exact factor. And I've already found my slant asymptote. So that's as far as you need to go on your test, as long as you're sure that there is a remainder of some sort. It shouldn't go in evenly if it's an asymptote. So y equals x minus 7 is my slant asymptote. Whenever you do division, it's a slant asymptote. And then it says find the domain. Remember that domain is directly linked with your asymptotes. So it would be x does not equal -1 and x does not equal -2. So I put that on there to like help you remember that, how to write a domain correctly. Your range, you should always look at your graph to see what the range is. I didn't ask you the range, but if you are graphing them by hand or you have a calculator section, I would definitely take the time. Oops, What is this? X cubed minus 4x squared. Oh, struggling. X squared divided by x squared plus 3x plus 2. So let's just see what this comes out to as a graph. So remember how you said something about x squared? See how it's bouncing off the x-axis at that point, and then it's cutting through this other x-intercept? It does have, it had two asymptotes, didn't it? One is at -1 and one's at -2. So I'm wondering if I zoom out, if I'll see the other. So here's this other arm. So see how it had a slant asymptote like this? I would not expect you to graph this one by hand because you wouldn't be able to do this step probably, but it's guiding along this asymptote here. This would be too hard to graph it by hand. That's why in this example, all I had you do was answer the questions. All right, I'm gonna do with you number 3, but I'm gonna give you like a few minutes to try number 3 on your own first. Kind of like it's a test question. It's going to have a couple vertical asymptotes, so it might be challenging to do the graph. So when you get to the graph, if you want to practice with a calculator, just to double check what it looks like, that's fine. I'm not going to give you 2 vertical asymptotes on the test to graph by hand. So we'll do the answers to number 3 in a minute. All right, so if we answer our y-intercept first, when we plug in 0, we get 8/24, which is 1/3. So you could either write that as 0, 1/3, or 0, 8/24. So that's here on the y-axis. Then our second step is usually looking for our x-intercept in the numerator, which in this case, the number 8 is sitting there. So there is no x-intercept because 8, there's nothing I can do to it. It's always 8. So there is no x-intercept. Vertical asymptote is usually my third step looking at the denominator. When will that be 0? So let's see, this factors into x, what? -6, x minus 4. So my vertical asymptote is at x equals 6 and x equals 4. So this is not going to be a great one to have to graph by hand, but oh. So it's just tricky to get 3 different quadrants, so I wouldn't have you graph this one by hand, but this is a good practice. All right, horizontal asymptote is what? Denominator has the greater power. So this is the only one we haven't practiced today. So first we stripped the coefficients, then we did division. This time it's going to be y equals 0 because 8 divided by like a really big number, if this gets really big, is going to be 0. So it's a horizontal asymptote at y equals 0. That's why there was no x-intercept. All right. So now I know that this region of the graph probably looks like this. Find the domain. X does not equal 6. X does not equal 4. These 2 regions are going to be kind of tricky to graph. This is probably cutting through the axis, or it's a parabola. So at this point, I'm going to move to the calculator for this type of graph. I'm not going to do a double vertical asymptote on the test without a calculator to use as a reference. X squared minus 10x plus 24. And so there's that elbow. Oh, and then this has a tiny little parabola down here and then another elbow up here. So I could have figured that out if I plugged in some points, but sometimes it's trickier to figure out parabola little shapes because how are you going to plug in one point and know what that elbow looks like? Whereas up here, you could have kind of assumed that that was an elbow.